Hey there, what's up guys? So welcome to the second session for polynomials for grade 9 students. So let's just have a recap of what we have learned in the first session of polynomials, okay? So we have started with the basic concepts, like we have taken a recap of what we have learned in the class 8 algebraic expressions, which is the term, coefficients, all those algebraic expression, all those basic things, variable, and we have all classified polynomials based on their degree into linear, quadratic, cubic, biquadratic, right? As well as we were about to begin with value of polynomial. So today we will complete this value of polynomial. We will even I'll introduce a new topic, division algorithm, and we are gonna cover how to identify if that expression is a polynomial or not. So let's begin with value of a polynomial, okay? Value of a polynomial. So let's say if there's something polynomial p of x, okay, and this p of x is equal to, let's say, any polynomial, okay, x square plus 3x plus 1. Let's say this, if p of x is equal to x square plus 3x plus 1. Now, how to find value of a polynomial? If they give they can give question like, find the value of polynomial if for p of minus 1. They can ask question like, what is, if they can give you this will be given, it will be given in the question, okay, this will be given in the question that p of x is equal to x square plus 3x plus 1, and they can ask you what is p of minus 1. So you should just do simple process. Just if this is p of minus 1, okay, let's take for example p of x equal to x square plus 3x plus 1, then what would be p of alpha? So if there is p of alpha, just replace that alpha with this x square plus 3x plus 1. So it would be alpha square plus 3 alpha plus 1, right? If it is for p of alpha, just replace that alpha with x in this given polynomial, right? You should replace that alpha only with the given x's in the given polynomial. So now they gave the question is that find p of minus 1. So now you need to replace this minus 1 with all the x in this given polynomial. So let's replace. So minus 1 square whole square plus 3 into minus 1 plus 1. Okay, for the calculation, minus 1 square is plus 1 plus of minus 3 plus 1. So 2 minus 3 is minus 1. So we found an answer that p of minus 1 is equal to minus 1. This is simple, right? So value of a polynomial is like they'll give you a polynomial that, and we should assume that p of x is equal to, so this is the procedure how to solve. So first we should write that p of x is equal to the given polynomial, and then the question, which is p of what value we need to find. If it was p of 2, just replace this x with 2. If this was p of 2, I'm writing it here. We should replace 2 square plus 3 into 2 plus 1. It would be 4 plus 6 plus 1. It would be 11. Okay. If it was p of 2, it would be 11. P of 2. If it was p of minus 1, it would be minus 1. So they can ask you like this any value, like p of x, this is p of x is x square plus 3x plus 1. They can ask you in terms of like they can ask you the value of x here as any constant polynomial, you can say, like any number, and then you should just replace those that constant polynomial with the x here, and then you should calculate it further, and then you'll get an answer. So for p of minus 1, according to this question, it is minus 1 is the answer. So now let's take another example, how to solve this value of polynomial. So let's take if p of x this is given in the question, remember that, if it is 5x square plus 2x plus 7, if this is given in the question 5x square plus 2x plus 7, then find the value of p of 2 minus P of 1. Now how to do this? So first we need to find the value of P of 2, and then we need to find the value of P of 1 and then subtract it. Like I already told you how to find the value of each P of 2, P of 1. Now let's first find the value of P of 2. So first write it in the question, right, and while solving, write that P of x equal to 5x square plus 2x plus 7. Then P of 2 will be, you should just replace this 2 with the given x in the polynomial, plus 2 into 2 plus 7. 5 into 4, 2 square is 4, 5 into 4 is 20, plus 2 into 2 is 4, plus 7. So 24 plus 7 is 31. So P of 2 is 31. Now let's find out the value of P of 1. And then at last we need to subtract it, okay? So P of 1 is 5, I'm just writing it directly, 5 plus 2 plus 7, it is going to be 14. Okay, now let's subtract P of 2 minus P of 1. P of 2 minus P of 1 is what we gonna do. P of 2 we know the value of is 31, minus 14 is the value of P of 1, and 31 minus 14 gives us 17. So 17 would give you the answer of P of 2 minus P of 1, right? They can ask you tricky questions like this. P of 2 minus P of 1. In this question, what do we need to do? The usual process, we need to find out first P of 2, and then next we need to find out what is P of 1. Okay? So now let's move on to the next topic. So remember this value of a polynomial, many questions can be asked from this. So now we are going to move to the next topic, which is the identifying polynomial, right? Identifying a polynomial. Okay. So they can give you any expression, right? You can say any number in terms of variables and constant polynomials, and they can ask you that if that whole thing is a polynomial or not. So let's deal with the first example. Let's say if it's 3x square plus 2x minus 1. Now if this is given, okay, now we need to identify that is this a polynomial or not. Now how do we do that? Okay, so the first step is that solve this equation, right? Make it into simplest form. I'll just write it here. Solve it so that it will come in the simplest form. Okay, first is make it into simplest form, but here we have all different variables. Here x power 0, because it's for a constant polynomial, we can assume, so here degree 0, here degree 1, here degree 2. So this is the simplest form. We cannot make it more simple. Okay, so this is simplest form. Now the next step, what we need to do, okay, the next step is see that the powers of these variables in the given polynomial are whole or not. I mean, you should check these the powers are whole numbers or not. Check, second step, okay, check the powers are whole or not. Whole numbers, I mean, okay, whole or not. Now in the second step, we can identify easily that this is a polynomial or not if those are not whole numbers. Like for example, if this was 2x 1 by 2, the power, right? I'll just write it here. If this was 1 by 2, this power, instead of being 1, if it was 1 by 2, then you can say that this power is not a whole number. So you can say that this entire thing, right? This entire thing is not a polynomial. Right, it's not a polynomial. Remember that. But if in case, which we have taken first, 3x square plus 2x plus 1, okay, here we don't see any you can say we don't see any fractions. Okay, we only see whole numbers, which is 2, which is 1, and here x power 0. So only there are whole numbers. So in this case you can say that it is a polynomial. Now let me give you examples where few where there are not polynomials. Okay. So I'm sure you remember the rules, right? The first step is I wrote it all wrong, but here the first step and the second step. First you need to let me give you a problem first. Okay, let's say 7x minus x power minus 1 plus 1 by x. Right? This is the given polynomial. Now the first step I told you, it is you should make it in simplest form. Now can we make it in the simplest form? Yes. So 7x minus x power minus 1 plus 1 by x. Now 1 by x, if it most of the numerator will be x power minus 1. So let's write it as x power minus 1. So there is plus x power minus 1 minus x power minus 1. Cancel these both. So remaining is 7x. Easily we can say that it is a polynomial. So if you do not follow the rules of those two rules, right? First simplest form and then identifying that those are whole numbers or not. If you simply start with whole numbers, right? You can first say that this minus 1, it is not a whole number. Okay, well? And after that, if this x is moved to the denominator, it would be it would be x power minus 1, and you will say that this is also not a whole number, and then you can easily conclude this is not a polynomial. But you need to simplify it. After simplifying only, we'll come to know the result is 7x, and then only we can say that is a polynomial. So if you do not follow in that same order, then you wouldn't get the result. Let's take another example. 4 power x minus 4x power minus 1 plus 3 x. Okay. So is this a polynomial or not? So you can't simplify this anymore, and this is the okay, I'll write for 3x squared, right? And this is in integer negative. It is not a whole number, not a whole. So this whole thing is not a polynomial. Okay. Now I'll give you one more example in terms of roots and fraction, the powers being in a fraction. Okay. So let's say if this is root x, right, 2 times of root x plus 3x square. Is this a polynomial or not? Now root x can be represented as x power 1 by 2, am I right? X power 1 by 2 times 2 plus 3x square. Now here 1 by 2 is not a whole number, right? It is a fraction. It does not come under whole number. Whole number means 0, 1, 2, 3, infinite. Okay. So this thing is not a whole number. So you can say that this is also not a polynomial. Not a polynomial. Simply you can say. Now let's see last example. So this is example root 2x. X is not under root. Okay, root 2 times x plus 4x square minus 7. This is a polynomial or not, right? Now observe this carefully, right? This root is not under this is no root, right, for x. This is only for 2. Root 2 times x. Okay, so here there is 2, here there will be 1, right? So if then you can easily state this again as a polynomial. If there is a root for the constants, right? If this constant polynomial, then if you simplify it will be 2 power 1 by 2. Do not care about this constant polynomial at all. Only the variables power is important. Only those will be, if those are whole numbers, then you can say that this is a polynomial after simplification, remember it. So identifying a polynomial is over now. Now let's move on to the next topic. Division algorithm. Fine? Division algorithm. So this is we are going to discuss about division algorithm. So you can express dividend. You already have studied this long back. So dividend, you already know it is equal to divisor into quotient plus remainder. plus remainder. Okay, dividend equal to divisor into quotient plus remainder. Main thing to remember. Now this dividend, now they can ask you questions like they'll give you a polynomial. They'll give you two polynomials actually. One will have a greater degree, other will have a lesser degree, and that would be the divisor and dividend. And they'll ask you whether the divisor is a factor of the dividend. They can give you two polynomials. Let's just say x square plus 3x minus 1 is a polynomial, and x plus 1 is the another polynomial. These both. Now they are asking us that if this polynomial is a factor of this polynomial. Now let us find it how. So first step, let's take examples first for constant polynomials. Like if they give if this is 15, let's assume 15, and this x plus 1, let's say it as you can say any 6. Okay, so 15 is how can we express this 15? We can express 15 as 6 times quotient. Let's say 2 plus, it cannot be 3 because 6 times 3 would be 18, which is much more than 15. So 6 times 2 plus 3. Now here we are getting this as the remainder, and this as quotient. 2 as quotient. Now this is a 15 can be expressed as, okay? And here if the remainder is not at all 0, then you can directly say that 6 is not a factor of 15. You can also see, if you want to, I'll just prove it. 15 factors are 1, 3, 5, 15. That's all right. Here, can you find out 6? No. So you can easily say that 6 is not a factor of 15. And if they give you polynomials, right? And if the remainder, if you find it out as 0, then you can say that this polynomial is a factor of this polynomial. Now let's take these examples. X square plus 3x plus 1. Okay. So no need of these examples. I'll give you one more example. So 2x cube, okay? 2x cube plus 2x square minus x, and the other one is x. I teach you the division of binomials later, okay? So x. Now let's divide this 2x cube by x, okay? We know that this degree is less than this. So x, if we cancel it, we can further write it as 2x square plus 2x minus 1. Now this is the quotient which we got, okay? So we can express 2x cube in form of dividend, right? 2x cube plus 2x square minus x is equal to, you can say that it is x, which is divisor, times quotient, which is 2x square plus 2x minus 1. And did we divide this completely? Yes. So the remainder would be 0. So if the remainder is 0, you can directly say that x is a factor of 2x cube plus 2x square minus x. So that's all for today, guys. So thank you for watching this video. If you really do like it, so please hit on the like button, please do share and subscribe. So in the next session I will tell you about how to do long division method and about division of binomials with trinomials or anything with binomials. Here we did monomial with a polynomial. Later we'll know about binomials with a polynomial, right? So thank you for watching our video, guys, again. So I'll meet you in the next session.